Hello, and welcome to your CNET Tool for Week 9 video. This week we're going to look at Assignment 1, which seems a bit late for Assignment 1, but with everything that it entails, we had to get a whole bunch of fundamental content out of the way. So we're going to look at the Assignment 1 summary. We're going to look at accessing the GitHub Student Developer Pack and all the fun tools that you get in that. We're going to use some of them in this course. We're going to talk about DNS, the domain name system, and how it works. That's one of the things you're going to unlock in the GitHub Student Developer Pack, is some free domain name options. We're going to talk about TLS and SSL, Transport Layer Security and Secure Sockets Layer, and the Web Accessibility Initiative, or WAI. And Assignment 1 is going to cover all of these, which is pretty awesome. We're going to add some functionality to our website. So in Assignment 1, you're adding several features to the website that you've learned to build in Labs 1 to 8. You're going to register a domain name for free using the GitHub Student Developer Pack. You're going to generate a TLS SSL certificate using certbot and Let's Encrypt, also for free. You're going to configure your www instance to use HTTPS and configure your security group to allow incoming HTTPS traffic from anywhere. So from this point onwards, you're going to be able to access your web server with a fully qualified domain name using HTTPS. Isn't that great? Then you're going to research the Web Accessibility Initiative and implement any two of the standards that haven't already been met. And I've left it pretty wide open there. There's a lot of stuff you can do with this. Try not to dive too far down the rabbit hole when you're doing the research. And we'll look at some examples of things you can do in the demonstration video. I'm not going to demonstrate all of the things in the demonstration video this week. I'm going to demonstrate some of the key ones, but you're going to have to do some research on them. And then you're going to use this to add a new web page to your website as well, and give me a 250 to 500 word write-up about the WAI standards. What did you implement, and why is it important? Well, doesn't sound too bad for an assignment, does it? It builds on everything we've done and adds some functionality at the same time. So the GitHub Student Developer Pack is where we were going to begin, right? It gives you access to a whole bunch of industry tools, 80 plus industry tools for free. And this includes, as of this recording anyway, the following 3 offers to register a free domain name, free for 1 year. You can get a free .me domain for 1 year through Namecheap. And that's the one I'm actually going to show you how to use. You can get a free .live domain for through name.com. Again, free for a year. I think free for a year. It doesn't actually specify on the page where I got this screenshot from. And you can get a free .tech top-level domain for a year. Isn't that great? So 3 options there that you can use free for a year. And you can renew that as long as you're a student. You can just keep applying for that discount and get it at a discounted rate. Now, some of these, like Namecheap, they give you a bunch of free domain names, but they also give you some at a discounted rate. I'm not saying go pay for something, but you could if you wanted to. Not necessarily for this course, right? But there's free options here. Use the free options. Because they're free and they're awesome. So, since we're implementing DNS, we kind of need to talk about DNS and how it works, so you have an understanding on what you're doing. DNS is one of the key technologies behind how the internet works. The very first implementation was Bind, the Berkeley Internet Name Domain, which was developed for Unix in 1984 at UC Berkeley in California. It's a hierarchical, distributed system that maps IP addresses to human-readable domain names, like www.google.com. This is why you don't have to memorize websites by IP addresses, right? You just type in a name, and it's all done for you. That's the magic that makes it work, DNS. All of these domains, well, every domain, descends from root. And it's represented by a single dot at the end of the fully qualified domain name, or FQDN. Early web browsers actually required an inclusion of that at the end of the URL. Thankfully, we don't need to do that anymore, and we haven't needed to do that for like 30 years. But it's still represented there when you look at DNS records, so it's important to know that it's there. DNS addresses are read from left to right. Right to left, not left to right. Like backwards for, at least for the English-speaking world. We're not used to reading that way, right? Some cultures do. We do not. So the top-level domain, that's at the end of the URL. And that can usually consist of like a .com or a .ca. Those are the ones you're used to seeing, .org, .net. Next you have the apex domain, and then you can have subdomains within there as well. www is technically a subdomain. So for example, I'm going to use the URL that I've been using for the lab sites, which I know you know how to get to because I've put a link to them in every single video, and also that's where you've been finding the lab instructions. So cnet204.jmcarmen.tech. .tech is the top level domain. And there's technically a dot at the end of that we don't have to put in. The browser just invisibly does it for us. But it's technically there. So .tech is the top level domain that descends from root. Next we have jmcarmen, which is me. My middle name's Michael, that's where JM comes from. And then cnet204, that's the subdomain. So I can have many other records within jmcarmen.tech that point to other websites if I so choose at any other point. Now when you're creating DNS records, there's a variety of ones that you can create. Different types used for different purposes. We're only going to cover a couple in this course, and this is not a complete list, but there's quite a few. A records. We're going to use an A record. A records are address records. They map a host name to an IPv4 address. For IPv6, you use a quadruple A record instead. And you're going to add an A record in assignment 1, and you're going to do some DNS in assignment 2 as well. CNAME records, or canonical name records, these are used to provide an alias for another existing A record. And you're going to add a CNAME record in assignment 2, which is towards the end of the course. It's in a few weeks. We're actually kind of getting towards the end of the course, aren't we? Text, TXT records, or text records, they're used to store information about your domain. They can be used for a bunch of things, like verifying your domain ownership, making sure you own the domain, for configuring SSL. It's an important thing. You could also use these to prevent email spam. There's all kinds of purposes for these. MX records are mail exchange records, and they provide information about mail servers for your domain. We're not going to be doing anything with this for this course, so you don't need to worry about it. Just be aware that it exists. PTR records are pointer records. They're commonly used in reverse lookup zones. So those are the ones that map the IP address to the host name instead of the other way around, host name to IP, right? Which we're not going to do anything with pointer records. Now, once you've configured DNS, and you can do this for anything too, not just with configuring, but these are useful troubleshooting tools, you're going to want to use some commands to query your name server and make sure everything works. It's great for confirming and troubleshooting issues when you're first configuring things, and because you're using a domain registrar, you're going to be able to use these tools from anywhere, from any device that has them. Because once you've configured your DNS records, It's live, it's real, it's on the internet, which is awesome to be able to do something like that in a college course. So the first one we're going to look at is NS lookup. NS lookup takes you into an interactive DNS lookup mode. You can issue as many queries as you want, and when you're done, you can use the exit command to quit. This one is available in, this one being NS lookup, it's available cross-platform in Windows, Linux, and Mac OS, so you're not locked down to a single operating system here. Host is a command that will give you the corresponding information for any DNS lookup. If you give it an IP address, it'll give you the host name. If you give it the host name, it'll give you the IP address. It works in Linux and Mac OS, which I know many of you are probably working from a Windows machine, but we do have access to our Linux instances in AWS, right? So you could just access those. If you're working from a Mac, well, you can do this from anywhere, right? I'm working from a Linux machine, but I'm doing everything in a Windows virtual machine to try to force myself to do things in Windows, because that's what the majority of the world uses, right? Now, dig is another handy command. It will give you a whole bunch of detailed information about a DNS record and all of the records that it maps to. This works in Linux and Mac OS, but there's a browser-based solution, the Google Admin Toolbox, and I linked to it here. So that gives you a web-based ability to use dig. So you just put your query in there, and it'll give you all the information. These are going to be extremely useful tools for troubleshooting DNS in assignment 1 and 2, because trust me, it's pretty tricky, and you might make mistakes. In fact, you're probably going to make mistakes. When I first learned DNS, I made mistakes. I tell this story all the time when it comes to DNS. I remember I was working on an assignment in, I want to say, my 5th semester, and we had to configure our own domain. Each student had to configure their own domain, and we had to send email by fully qualified domain name from our mail server that we set up to any other student in their class's domain, and they had to receive it and be able to send it back. There was a lot of complicated moving parts, and we're doing this all on virtual machines on physical hard drives, not in the cloud at all. I once spent, while working in the open lab with a friend, I tell this story all the time, 3 hours, I think it was about 3 hours, going through my configuration and his configuration line by line, side by side, because I was missing a single dot. Now, I didn't know I was missing a single dot. It took me 3 hours to figure out that I was missing a dot in my configuration, and that's why it was double appending the domain name. Do you think I ever made that mistake again? No. So you're going to make mistakes. Learn from them, right? I always look, as soon as something's not working right, I always look for dots now. You know, CSS and JavaScript with semicolons. Other languages have their own things too, right? But troubleshooting is a useful skill. And I'm trying to throw just a little bit in here because you're going to have to be able to solve your own problems. Now, since you're a college student, you have a professor, me. You can ask me when something goes wrong. I can help you sort it out. It's a handy thing. But I want to show you how to fix it too, because that's important. Here's what using NS lookup looks like. So we type NS lookup. We're in our interactive configuration mode, and I'm looking up www.jmcarmen.me, and I see there's the non-authoritative answer, the name, and the IP address that it's mapped to. Now that's an elastic IP on an AWS instance. Isn't that great? Here's what using host looks like. So this is from within AWS. Host, and then I gave it the fully qualified domain name, and it gave me the address. I could have also put in the screenshot here host and the address, and it would spit out the reverse, right? The address and then the fully qualified domain name. You can use it both ways. And here's a sample of the dig command. So you see, we see a whole bunch of useful information in here. We see our fully qualified domain name, www.jmcarmen.me, and look, there's the dot that you don't usually see at the end. It's an address record, an A record, and there's the IP address that's been associated with it. Lots of useful stuff. Depending on what you're using with Dig, you might get some more information. In this particular example, I only had one record that mapped to my my instance in AWS. But you might see some more stuff. And this is what using the Google admin toolbox looks like. So you see, we see a lot of the same information we got in this previous one. I flipped back, I'll go back. But we see it in a cleaner, much cleaner format. So I gave it www.jmcarmen.me. And I see I've got an address record, there's the IP address associated with it, and its time to live is 30 minutes, which I believe is the default in with Namecheap. You can change that. What that means is if you make a change, you have to wait 30 minutes or flush the cache, right, and force a new lookup for it to populate globally. And since we're doing everything with real servers, like this is going to, and real tools, this is going to be accessible globally. Next, we're going to look at adding some security with the transport layer and secure sockets layer, TLS and SSL. Really, we just use TLS. So HTTP, which we've been using so far, just as a refresher, is a protocol or a set of communication rules for client-server communication over any network. Right? We've been using this to access our web server and view web pages on it. HTTPS allows you to establish a secure TLS or SSL protocol on an insecure HTTP connection. So before connecting to the website, your browser will use TLS to check the website's TLS or SSL certificate. These certificates show that the server adheres to current security standards. And you can even find out information about the certificate within the browser's address bar. I'll show you this when we do the lab, if I remember. An authentic and encrypted connection will display with HTTPS : instead of HTTP : And you should know that because, well, we've been having to get rid of the S since we created our first web page, right? Now that additional S stands for secure. The term SSL certificate is still commonly used in industry, even though everything now uses TLS, or should, because SSL is deprecated. SSL has been around since 1995 as SSL version 2. Version 1 was never published. TLS is the successor to SSL, and it first released in 2006. All versions of SSL have been deprecated, and TLS versions 1.2 and 1.3 are supported still, but 1.1 has been deprecated, and 1.0. So really when we say SSL, we mean TLS, and that's why I wrote it as TLS/SSL, right? Because we're academics. We want to be specific. Here's all of the different versions for SSL and TLS and when they were published and when they were deprecated. So version 1 for SSL was unpublished. Version 2 was published in 1995, deprecated in 2011. That's a long time. We're going to be using TLS. I think we get version 1.3 with Let's Encrypt, and that's that was published in 2018 and has been in use ever since. That's the most recent up-to-date version. That's the one we're going to deal with. So after we layer on those things in our assignment, configure DNS and SSL, so we're adding some more standard tools, right? You're going to be able to access your web server with a fully qualified domain name using SSL after this, which is pretty awesome. It's a real web server. It's almost like we're We're configuring real stuff in a real place. We're going to look at the Web Accessibility Initiative. And we're going to start with a quote from Tim Berners-Lee, who's the inventor of the World Wide Web. Very famous guy. I think we talked about him in Lecture 1, didn't we? I seem to recall we did. The power of the web is in its universality. Access by everyone, regardless of disability, is an essential aspect. The web, or the internet, is fundamentally designed to work for all people, whatever their hardware, software, language, location, or ability. And when it meets this goal, it's accessible to people with a diverse range of hearing, movement, sight, and cognitive ability. Thus, the impact of disability is radically changed on the web because the web removes barriers to communication and interaction that many people face in the real world. However, websites can be badly designed, right? Websites, applications, technology, and tools. And when they're badly designed, they create barriers that exclude people. So as developers, remember I said a while ago, I want you to start thinking about yourselves as developers. You need to understand these tools and standards and be able to meet them. This is going to be the research portion of the assignment. We'll look it over together, and I'll do some of it together, right? I'll mention some stuff that's pretty easy to fulfill the requirements in the assignment, but I'm not going to do it for you. You got to do some research there. So in assignment 1, you're going to research and implement the Web Accessibility Initiative, which you're doing at the end, technically, but I stuck it at the top. You're accessing the GitHub Student Developer Pack. There's instructions for that in there, and I mentioned this back in Lab 4 when we set up GitHub initially. You're going to use an online service to register a domain name. It could be Namecheap. It could be one of the other ones we get, name.com or tech. You're going to use a certificate authority, in this case Let's Encrypt, to generate an SSL certificate. I said TLS SSL certificate there, but we commonly refer to them as SSL certificates. And then you're going to add that to your Apache server configuration. And you're going to do that using certbot, which automates the whole process. It's pretty awesome. It's actually really easy to do. And that's going to be it for this week. There's no lab this week. This is your assignment. Which, for the due date, have a look at the website and eCentennial, right? Next week, we're going to continue on with our labs. We'll do Lab 9, which seems insane. There's only 10, right? And in Lab 9 next week, you're going to learn about how to embed audio and video natively in HTML5. With that, take care, be safe. I will see you in the next video. Bye for now.